LASPATED offers two functions to visualize the spatiotemporal discretization information. These are functions that write into files the spatiotemporal discretization. The first method is write arrivals. And we need to pass as argument the name of the file. Let us say arrivals.dat that will contain the events with enriched spatiotemporal discretization. And we also have another method, write regions, that allows to write in a file the information corresponding to spatial discretization. It takes a while to write these files. Let us use now the write regions method. And it also takes as argument the name of a file. Let us say neighbors.dat that will contain the spatial discretization information. And now I will show you these files, arrivals.dat and neighbors.dat, that we have just generated with these LASPATED functions. Here is the file arrivals.dat. So you can see that the first line gives the dimensions of A that we had printed before, 7, 48, 5, 3, 226, 4. So the first four numbers correspond to time discretization. Then 226 is the number of subregions of hexagons in the discretization, in the space discretization. And 4 is the number of arrival types. And then what do we have in every line? Then we have all possible combinations of the indexes corresponding to the observations that we have in the history of calls. For instance, in the first line, or let us take the second line here. The first index 0 here correspond to the day. So here in this second line, in this, say it is the second line for the observation, but the third line of the file. In this third line here of the file, the third line corresponds to the day with index 0, the time window of 30 minutes with index 0, the block of months that we have defined in the third discretization with index 0, the index 0 for the last time discretization that we have defined. So these are for observations that are neither carnival, neither January 1st. Then we have the index 6. This is the hexagon with index 6. And then we have the priority of the call, which is 3. Then we have the number of the observation. So this is observation the first observation with index 0. And in the last column, we have the number of calls that we have observed for these combinations of indexes and for the first observation, and so on for the subsequent lines. Now let me show you the file neighbors. Here is the file neighbors.dat. In the first line of this file, we have two numbers. The first number is the number of subregions of the space discretization, 226 in our case. And the second number is the number of regressors for our application. This is 5. It corresponds to the population plus the 4 land types. And then every subsequent line of the file corresponds to a subregion. So for instance, in the second line, we have the data corresponding to the first subregion with index 0. In the first column, we have the index of the subregion. Then in the next two columns, we have the coordinates, latitude, longitude of the centroid of the subregion. Then we have the values of the 5 regressors. The first one is the population in the subregion. And then for the next 4, we have the areas or the 4 different land types. And then we have pairs of values, a number of an index of a neighboring region, and the distance between the region and this neighboring region. So for instance, for this region with index 0, the neighbors have indexes 107. The distance from region with index 0 to region with index 107 is 2.414. Then another neighbor has index 144. 2.501 is the corresponding distance. Then we have another neighbor with index 203. Next comes the distance between this neighbor and the region with index 0, and so on. We then have another pair of values, the neighbor with index 115, with corresponding distance 2.505 to subregion with index 0, and finally the neighbor with index 40 with the distance 2.503 between the centroid of the neighbor with index 40 and the subregion with index 0. So these files, arrivals.dat and neighbors.dat, contain all the information generated by the space-time discretization of LASPATED. Let us now go back to the Python command window. I will quit this command window. And I would like to illustrate LASPATED space-time discretization functions with another choice of time discretization, actually a much simpler time discretization, where we will be interested in counting the number of observations only for every day of the week. So we will have a periodic model with period 1 week. And then I will show you the corresponding files, arrivals.dat, which is one of the final outputs of the discretization process. So let us go again through all the steps until the production of this arrivals.dat file. And since I have been in detail through all the comments necessary to the production of this file and of the space-time discretization. I will be quicker on these comments now. First, starting again to import our libraries, creating the LASPATED data aggregator object, reading the events, adding our events to the data aggregator object. Let us say that we will use as the border the city of Rio de Janeiro. We can, if we wish, again, visualize the corresponding border, which is the studied area. So we will visualize again the city of Rio with the calls on the map. Let us go back to the Python command window. Then we will add, say, rectangular discretization in 10 by 10 rectangles. And as I was saying, I would like now to illustrate a simple time discretization where we want to count the observations for every day of the week. So this is how we have built the corresponding time discretization. We can still read the regressors to compute now for every rectangle the population and the areas of the different land types. This is how we did that before. We now compute the population for every rectangle. And then we read the land use information and we compute the areas of every land type for every rectangle. We obtain the space-time aggregated information with the get events aggregated method. And then finally, let us produce the file arrivals.dat corresponding to the space-time discretization that we have just built. Now this file was generated. Let me open this file and let me show you this file. So here we have a much simpler space-time discretization. In the first line, we have the number of indexes for time discretization. So this is 7. We have a model which is periodic with period 1 week. And the elementary time windows have a duration of 1 day. So the first number here, 7, is the number of time indexes, the number of days during the week. 76 is the number of subregions, the number of rectangles of our rectangular discretization. Actually, of the 100 rectangles of the 10 by 10 discretization, 76 have an intersection with the city of Rio. And the last number, 4, is the number of features, which is the number of priorities, of call priorities in our case. And then every subsequent line will correspond to a combination of the indexes, time index, space index, and priority index, plus an observation number and a number of calls. So for instance, in the second line here, the first 0 here means that this line corresponds to observations for day with index 0. The 2 here means that the observations are for the rectangle with index 2. The 0 in the third column means that we are here interested in calls of priority 0. And the 0 here means that we are looking at the first observation for these combinations of the indexes. And for this first observation, we have observed one call. So when this combination 0 to 0 will appear again, instead of 0 in the fourth column, we will have a 1, meaning that for day with index 0, for subregion with index 2, and for call of priority 0, for the second observation, which will have index 1, since the indexes start at 0, we will put in the last column the number of calls that we have observed for this combination 0 to 0 of the indexes for the second observation, and so on.